Hi viewers, welcome to LMS Solution. Today we are going to see about solar PV array could brushless DC motor one. This is a Simulink model, and then this model is developed based upon this paper. So this paper we refer this block diagram, and then we refer this specification of BLDC motor, and then specification of PV array, and then we refer this boost converter design, and then we refer this design of water pump. Based upon that, we design this Simulink model. So here you can see that the Simulink model having solar PV array with the maximum power of around 2237 watts, and then operating voltage will be 238 volt. Is a rating of that PV array, and then it going to be connected to the BLDC motor. This BLDC motor rating is 1.8 kilowatt. So this is a rating of that BLDC motor, and it going to be connected. That means this PV going to be connected to the boost converter, and then this boost converter will be controlled by means of conductance. Here you can see that this is the incremental conductance MPPT. So the incremental conductance MPPT is in to input voltage and current. Based upon voltage and current, we need to calculate this dV, dP and di, and then you have to apply these conditions. So this condition going to be calculate the new duty cycle. That duty cycle going to be processed via pendulum generator. So this PWM generator will be generate the pulse. This pulse going to be control this I in order to extract the maximum power from the PV array. And then here you can see this is the DC bus. Here you are going to apply DC bus voltage control. Here we are measuring the DC bus voltage, and when we compare with the 310 volt. Here we are going to maintain at 310 volt, and then it's going to be processed via PA controller, and then this PA controller will be processed via this PWM generator, and it will be generate pulse. So here we will have pulse, and also here we are measuring the Hall sensor. Hall sensor output going to be converted into back EMF, and then back EMF going to be converted into gating pulse. So here we will get the gating pulse. So this gating pulse and this impulse going to be combined by means of AND gate, and then when we finally generate the pulse for this voltage source inverter to convert this DC into the suitable form of BLDC motor. This automatically going to be control this speed and the torque of the machine. And then here we have taken that speed of the BLDC motor, and then is converted into load torque. And then here they have different scopes. Here you can see that this scope is for measuring the irradiation, PV voltage, PV current and PV power. And then this scope used to for measuring the back EMF, stator current and electromagnetic torque and motor speed. And this scope going to be used to for measuring the load torque of that BLDC. Here this simulation model going to be tested with the two conditions. One is constant irradiation condition. That means here we are going to fix the 1000 watts per meter square, and then you have to check the results. Here I am going to simulate the model. Here we are measuring DC bus voltage and the inductor current of the boost converter. So here I am going to simulate this model. So here you can see that the PV power almost around 2237, and then for 1000 watt per meter square, the PV voltage maintained around 238 volt, and then current will be maintained around 9 amps. So here you can see the DC bus voltage maintained around 10 volt, and then IL is maintained around the 6 amps. So here you can see there is a back EMF, and back EMF having the peak amplitude around 110 volt, and then this is stator current having the peak amplitude of 10 amps. This electromagnetic torque is having the around 6 Newton meter, and then this motor speed maintained at 3000 rpm, and then this load torque maintained at around 6 Newton meter. We can check the result for the paper result also. We will get this kind of result for 1000 watts per meter square. The same kind of result only we are getting. Here you can see that this result will be same. Both result are same, and then here we have PV detail. Here you can see that this detail both will be same, and then here you will have that load torque. Whatever result in the paper, same result only we are getting. So now I am going to make dynamic irradiation condition. That means initially and the irradiation will be 200, and then it goes to 1000, and again comes to 200. So it will be happen 0 second to 0.15 it will be 200. At 0.15 the irradiation will be 1000, and from 0.15 to 0.3 it will be 200 watts per meter square. So here I'm going to simulate the model. Then you have to check the result. Here you will see that for 200 watts per meter square, the power will be is around 400 something. And then after 9 to 15 seconds is changed to 1000. That's why we are getting around maximum power 2237 watts. And then here you can see for 200 is around 2 amps, right? For 1000 watts per meter is around 9 amps. And then here you can see that's a variation of PV voltage from 230 or 235 and goes to 238. This is changes of PV voltage, current and power. This DC post voltage and inductor current of the boost converter. According with the change in power of the inductor current also changing here. And then here you can see that back EMF will be initially very low because of power generation from the PV is very low. After increases in the irradiation from 200 to 1000, then we consider back EMF will be increases. You can see from the amplitude of the back EMF, and also you can see the variation of current for different irradiation condition like 200 and 1000. For 1000 watts per meter square, the current will be 10 and amps peak. For 200, the current will be having around 3 amps peak. So here also you can see the variation of electromagnetic torque according with the change in irradiation. Initially is low and is for 1000 is comes to 6 Newton meter. This is variation of speed of the BLDC motor for different irradiation condition. For 200 is around 1700 and then for 1000 is around 3000. This is low torque. We can check the result of the paper also here. We will get the same kind of result only. So here you can see that we are getting the same kind of result, and then here also you can see that we are getting same kind of result, and then this one here also we are getting the same kind of result. So this is working of this model. Thanks for watching your videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.